that stopped working?
No, this is one that sort of, I got it to work again, so I should be able to. All right, Leslie.
All right. So, I am presenting on predicting cyber threats. So what I mean by that is, let's say you had a security firm or some other type of company, and you want to protect your network against security. Are you going to purchase? Are you going to buy this company to come in on your network? Or are you going to do it internally and try to be cost effective and get the most value for your capital? So, with that being said, actually not yet. With that being said, what I want to talk about is hackers will capitalize on vulnerabilities within the system. So what you can do is, there's always going to be vulnerabilities in the system, but you want to measure the impact of each vulnerability to see which one to address and which one not to address, because it's impossible for you to address all of them, given that you want to make a profit and you want to be cost effective. So my first talk is about visualization and the idea of it. So these 4 data sets, 1, 2, 3, 4, have the same mean, variance, regression lines, standard deviation rates, but they all predict different things. They all graph out to different lines. So, I mean, this one would be easy to predict when your next vulnerability is going to happen. This one not so much. There, maybe. So, the idea of visualizing these type of things is essential. With major cyber events, these are by no means comprehensive. These are just the major ones made on like Bloomberg, Dropbox, LinkedIn. Those major ones are here. So with time, 2014, 2015, 2016, and the advancement of technology, that has not decreased the number of threats and vulnerabilities and attacks happening. So the motivations for these attacks have pretty much been the same. Cyber warfare has doubled in percentage from 2015 to 2016. Hacktivism has increased, so we see that the methods and motivations for these are cyber warfare for these organizations that want to compromise your network. So how would a company, and this is the breakdown by month, so you can see it decreased in September and October and increased in November and December. And the idea with that is that you can use these trends in these type of graphs to better allocate your resources and your money assigned to your company. And likewise, make decisions on what vulnerabilities to assess and what vulnerabilities not to assess. So the model I'll be talking about is how to measure the impact of vulnerabilities, assuming you know the vulnerabilities of the system. So there's this idea of a common vulnerability scoring system, CVSS, and it's this industry-wide technique that many companies use to just measure the vulnerabilities of their systems, the exploits of their system. And what it is that it's based on 3 levels, base, support, environment, taking into different combinations. You add those up and you get a number. Assuming this is just an example 1, you'll have your CVSS score 0 to 1. That's assuming you have 32 vulnerabilities. If you're in the green range, that's okay. If you're in the 9 to 10 range, you need to take severe action to assess your situation. And furthermore, dissect which ones to take care of. So, predicting the impact of vulnerabilities. I'm going to try to get through this pretty fast, assuming everyone has a basic understanding of statistics. With that, I'll be using a multiple regression model, which assumes 4 things. Linearity, which is individual linear relationships, multi-collinearity, no correlation between 2 or more predictors, and you can test that by the variance inflation factors, which is this over here. So this is x1, x2 is right over, x1 is right over x2 and x3. So this would fail. You cannot use multiple regression on this type of data set because clearly x1 and x2 are related. You assume homoscedasticity, which is the variance around the regression line is the same. You take an average. That's what's seen here. So you could use a multiple regression or a regular regression model, a linear regression for this. You cannot use it for this. And you assume normality, which which is modeled that you can your whole data set or a sample of the data set can be modeled using the normal bell curve, where your standard deviation means 34.1% away from 34.1% is one deviation away from mean 0. I also put over there the variance formula here, and then standard deviation would be the square root of that. So that's the basics. Those are the assumptions that are needed in order to predict the model. So we have our sample data set over there, where we have okay, so we have the CS score, and then we have the intercept, and then X1 and X2. So Y, this column right here, is the overall CSDV score. Because that process is done once the vulnerability is already known. Once you've already been attacked, you calculate this to see how bad is the damage. But what's the point of doing that if it's already done aside for documentation purposes? So this is going to allow you to predict the impact of future vulnerabilities and address them. So X1 will be the total number of vulnerabilities detected of the known system. X2 would be your network traffic, for that application, what you see, and you can get that like Wireshark. So step 1 would be the residual plot, this one right here. So residual just means that you have the actual graph, then you have the model, the actual, and the difference between that is modeled on the Y, and then the independent variable Y is modeled on the X. So with that, you can see that it's pretty linear, which is what we expected, what we needed to be a multiple regression model. Then we do a normal probability residual plot. So it's pretty dispersed out, pretty random, which means it's linear, which is also what we want. So the p-value calculated for this would be 0.02. And in the industry of statistics, it's assumed that it's less than 0.05. You're rejecting the hypothesis, which was that X1 and X2 do not affect Y. So rejecting it would mean that the total number of vulnerabilities of the system and the network traffic in the system do affect the CVSS score. So that's knowledge that we didn't know before, and now we can use. So the results. The top is just basic data that can be helpful, but what is useful here is the ANOVA table, which is an analysis of variance. And many people will use this kind of in the medical field, so to test different drugs to see on the control group, did it work? They'll create a model for that one and create a model for the one placebo, and if they are different variances, the drug works. If it's the same variance, the drug did not work. So what you want to do here is there a difference between your model and the actual data? And if there is not, then it's a good model. It's a goodness of fit test. So given your source, your regression, and your error, you can provide the sum of squares, the degrees of freedom, which is your total sample size minus 1, and then your F statistics, which is typically used when you are building a model based on previous data, and then your p-value, which in this case was 0, so the existence of a linear relationship. So the goal was to predict the impact of vulnerabilities. If you can predict the impact of let me reverse that. If you know people, hackers or anyone out there is going to exploit your vulnerability, so you want to get rid of it or address it, but you have too many to address. So if you can predict the impact of them, then you can predict which ones are better to take care of and prepare for those. So it's more on the you're being more on the offense than the defense. You're trying to see which ones in your system can you address and which ones can you not address. Those are references.
So is there any software, either commercial or open source that
There's like Minitab that will do these kinds of things. These are from Minitab, but anything that will tell you like straight. There's also software that will give you the CVSS score,
okay.
but one that will give you start to finish all of this, I don't know if there is. I think you can just use Minitab, CSDV, and then do it for every application, and then predict your future vulnerabilities and their impact.
Okay, thank you.